Hey everybody, this is Mr. Dan. I am going to be showing you a new programming language. It's called Sheerpower, and this is an introduction to Sheerpower programming. Sheerpower is designed for business solutions. You know, there are a lot of programming languages out there. A ton of them look very much like C or Java or JavaScript or Rust or whatever they happen to be. Another flavor looks a lot like Python. And PHP, that's another sort of flavor of them. Well, Sheerpower has its own look and feel, and it is designed for business solutions. Now, with that in mind, Sheerpower is definitely not for everyone. That's just not the case. Because languages like C and C++, they're really designed for developing compilers, device drivers, operating systems, things like that. Sheerpower, not that way. Sheerpower is designed to rapidly develop highly scalable business solutions. That's the plot with Sheerpower. In addition, it's got a really simple syntax, really simple design, has a rich set of high-level features, and it works well, of course, for developing applications that require extensive data manipulation, because that's what you do for business solutions. For Sheerpower, there's a lot of features. Of course, the development of this language has been going on for a lot of years. We're just recently re-releasing it. Recently re-releasing it, indeed. Major features include perfect precision math, which eliminates penny rounding errors. We actually received a patent for this. And the methods used to get rid of the problems that you have with pennies. Always a problem with traditional programming languages. And we'll take a look here. Here's an example. A little program in Sheerpower. It's fairly explanatory. You can take a look at it. You know, x is equal to 10.7 plus 3.2. You can see it, pretty simple. And we'd expect the answer, if you look here, to be 13.9. Pretty good. And we say here if x is equal to the expected amount, then we're going to print out, you know, it's like a print in any other language or a write statement. Got the value of, and then there's a semicolon, and then the value, which is whatever x is going to be, which hopefully is going to be 13.9. Otherwise, it says it's incorrect. And we'll run this program. And here we go, got expected value of 13.9. So yay, all worked perfectly. Other languages, such as Python, C, C++, they default to what's called an IEEE floating point standard for math by default. And we'll have the same program here. This is written in Python. If you know Python, you'll recognize the code. X equal to 10.7 plus 3.2. Here's our expected value, 13.9. If it gets the expected value, it's going to tell us the identical code, really, if you look. Here's our Sheerpower code, pretty close. Python code, pretty close. And now we'll take a look at that Python code and see what it looks like. We're going to run it. Python test.py, same program. Incorrect. Expected 13.9. What do we get? 13.8999999. It is not the right value. If you're doing compares to find out, did you add up all your dollars and cents properly? The answer is going to be no. You did not add them up properly, even though the answer really was probably yes, you did. Sheerpower has some other really cool advantages. It has virtually instantaneous code compiling. We can compile code at a speed of over 500,000 lines, not per minute, per second. 500,000 lines of code per second. This is not an interpret, it's actually a compile. It compiles into what's called bytecode, very similar to what Java does, but of course, really, really, really fast. This means that you can write a huge amount of Sheerpower code, and the time it takes you to make a coding change and then experience that coding change is almost always going to be way under a second, virtually instantaneous. In addition to that, we spent a ton of time, a ton of programming effort and tuning and all the rest of it to make Sheerpower have a super fast runtime performance for very high scalability. Sheerpower optimizes everything it can during compile time, and then again, which is unusual, at runtime. So during runtime, Sheerpower learns things about the way your code behaves and optimizes the behavior of functions that are called, string data that's manipulated. All of those things are sped up. There'll be some additional videos that we'll do that will go onto the internals of how Sheerpower manages to have the incredibly fast runtime performance and how it handles and achieves high scalability. Sheerpower also includes native high-speed processing of very large spreadsheets. These spreadsheets, when they're loaded into your program, we call them clusters. They're clusters of data. And for our example, we just have 10,000 rows. Sheerpower can handle 10 million rows, 15 million rows of spreadsheet data very, very, very quickly. And we're going to take a look at that. We have here a nice little spreadsheet. It has a city name and then the country it's in, the population of that country, the region, and the top 9,000 cities population-wise in the world. This data came from the CIA World Book, which keeps track of populations of various cities in various countries around the world. That total list, by the way, is 3 million. But I thought it'd be fun to play with this one. It's only 9,000. Sheerpower does work with spreadsheets at the rate of over 1 million rows per second. So we could have dealt with the full data set, but we thought this would be fun just to play around with. It's hard to scroll down if you have too many. Plus, Excel actually has a limit of 1 million rows. So it can't have more rows than that. Let's look at the code. If you remember here, if we take a look, we have a city, country, population, region, latitude, and longitude. Here's our cluster, as it's called in Sheerpower. We're calling it World Cities because that was the name of the spreadsheet. It has city, $ on the end means this is string data, country, population, which is a number. In Sheerpower, we don't call these, by the way, floating point values, like you hear said in PHP and things like that. This is a real, okay, meaning it's something that has a whole number and a fractional component. Also have region, and we have latitude and longitude, both as textual data. Normally latitude and longitude get passed around a lot by latitude and longitude. This is called geocoding when you do that. So this is what the spreadsheet looks like. Now we're going to input it into our program. We say cluster input. The name of the file is worldcities.csv. It has one header, as we noticed. And we'll go over here and take a look at that. It has one header right here. Okay. And we're going to load all of that data at once into World Cities. This statement alone knows how to read the spreadsheet, parse the spreadsheet, and load up all of these variable names, which are inside this cluster called World Cities. I'm going to assign a variable called suggested city with a lookup city for us. We're misspelling the word Los Angeles on purpose here, by the way, so we can demonstrate how cool it is that you can use Sheerpower to do data corrections. Now we have a little loop. And if we take a look, now we have a loop structure next. You'll see the do at the top, loop at the bottom. This is sort of an endless loop type of thing. And to get out of it, you have to, stop the program or have some exiting statement to get out. And we're going to start by asking for a line of input, asking the question city to find. This is how we get input from a user. We're defaulting to the suggested city, which if you remember was the word Los Angeles spelled improperly. And then whatever they type in is going to go into a variable, string variable, notice the $ on the end, called entered city. By the way, Sheerpower does support full declarations, so you can declare whatever you want to be a string or a real or a Boolean, all those things. Sheerpower has all those capabilities. So whatever they enter in for the city, we're going to save it under suggested city for next time. And now here's the cool thing. We've got a function in Sheerpower called find row. It says given this cluster, world cities, given this column in effect, city, if you remember, we're going to use the entered city here and do a lookup, and we're going to find out what row this city is on inside of world cities. And if the city, this function, by the way, returns a 0 if the row is not found. Okay. Rows start at 1 and go to the number of rows that we loaded in, not including the header. In Sheerpower, everything starts with 1. So if I have an array of 5 elements, the elements are 1, 2, 3, 4, and 5. They are not 0, 1, 2, 3, and 4, but you have to keep explaining that to beginning programmers. If you're doing searches on strings and you're looking for the word, the letter H and the word that, the H is going to be 2, TH, 1, 2. It's going to be the second. It's all because that method is called one origin, where other languages, Python, C, and so on, they use what's called a 0 origin. A bit more difficult, and people always mess it up. They dimension something or set up something with 5 elements, and then at some point, they index it by the 5th element, and then it fails. With us, that'll work, because our elements will be 1, 2, 3, 4, and 5. Great. So how does this work? We take the entered city, we search for it in this big cluster called World Cities. We find the row it's on. If the row is 0, which means we didn't find it, like Los Angeles, we're not going to find a city by this name. That's not going to happen. So it's going to say city not found. It's going to tell us what city they entered, and then it's going to run a routine called suggest a city. And then it's going to go back and repeat this loop. So we'll see how the find row function works again. We take the entered city. We're going to go through the world cities cluster looking for that city. If we find it, city row is going to be the row that it's on. And if it's 0, it means we didn't find it. Again, we're just reiterating that and decide if you want to include it or not. Okay, now we know, now we have a found city. We're going to romp through it in a loop. Here is an inner loop. You see the outer loop was the loop and the do. This is an inner one. This is a for statement. It ends with a next. It says start this variable called index at a 1. When it reaches the next here, it's going to be 2, 3, 4, 5. It'll go on forever until, of course, some conditions met, and we have a condition which says if this row is equal to 0, then exit 4. That's how we're going to get out of this. What does this loop do with find row? Well, takes the entered city, finds it like we did before, but index will be a 1, which means find the first occurrence of that city, and then index will be a 2, and it'll find the second occurrence of that city, because there could be duplicates. For instance, there's more than one Los Angeles in the world. In particular, there are 2, and we're going to see that in just a moment. If the row is 0, we're going to exit. Otherwise, from the world cities cluster, we're going to print out the city, and then a literal comma, and then we're going to print out the country. Continue to the next line here. And we're going to say population, and then we're going to take the population, we're going to make it all pretty with commas in it, and we're going to trim out of that any trailing and leading spaces, and then we're done. So let's run it and just see what it does so far. City defined, Los Angeles spelled wrong. We'll just take the default. City not found, right? We already talked about that. And here we have, it says there's an 86% chance that it's Los Angeles, United States, or 86% Los Angeles in Chile. Otherwise, maybe we meant Los Andes or Las Vegas, but it's suggesting Los Angeles now. We'll take that. And indeed, Los Angeles, US, here's our population, 3-point-something million. Los Angeles, Chile, a lot smaller. Let's put in something else. I'm currently in Cebu, Philippines, under quarantine. And let's look up Cebu, which is in the Philippines. There we go, Cebu, Philippines, population. And you see the population. So we see how that code works. Let's find out how in the world we did this part right here, where we were able to select the right city name by doing a spell correct. Let's see how that happened. Take a look at that. We look at this suggest a city routine. This is how you call a routine in Sheerpower. You just mention its name. Suggest a city. Let's go look at it. Here's suggest a city. And here's how it works. Sheerpower has a function called compare. Its job is to calculate the probability that one string matches another one. Here's a real simple example of that. Print compare. Well, you'll notice I dropped into a console window so I could play around. That's very handy when you're writing code as well. You want to test small pieces of code and see how they work. This is my last name, Espenson. Spelled wrong a lot. Most typical is Esbenson, like so. The compare function will now tell us the probability that when someone wrote Esbenson, it was really Espenson. And it says there's a 92% chance that that really was what they meant. How about Espenson? How about that one? Yeah, about 82%. But still, you know, possibly you meant that. And that's how the compare function is a really handy function. It is very useful for US names, not so much for other foreign names. It keeps track of probabilities also such as you're a touch typist and your fingers were on the wrong row of the keyboard. It knows where the rows are, it knows which keys are next to each other, and can compensate for that when doing the comparing. So it's not just sounding like something, although it does do that. It's also key positions on the keyboard and so on. So it gives you back a number. So this says collect from the cluster world cities, which means go through every row in world cities. And while you're going through each row, compare the city value that's on that row with the entered city. That gives us a number. We're going to sort descending, which means that the highest probability, like 100 would be perfect, will happen first, and then lesser probabilities will happen second. And we're sorting by that, so we're going to have them in order of most probable to least probable. Now we print out odds, we tab over to position 10, and then the city name, just to make a nice little table with some little underscores on it, really simple. This collect statement collected all of the rows in the particular order you wanted, which is descending. That's important to us because now we're going to go through that collection. The for each statement says go through each member of that collection of, in this case, world city rows, and for each one, each row in the order we specified, which was sorted by the compare. If you remember here, we'll look again. Okay, sort descend. Notice that we are sorting on data that doesn't even exist in the table. We're creating this data on the file, this compare function, so it's pretty cool too. And we print for each of the cities in the collection. We're going to print the compare that we do, which will get us our percentage on the comparison. And then we'll print from the world cities, the city name, the country, and then we'll increment a little counter, which we started up here at 0. We increment a counter, plus plus is the typical way you show incrementing of counters, and Sheerpower has that feature as well. If the counter is equal to 1, which means it was our top number 1 compare, we're going to put it into suggested city. So later when we suggest a city, we're going to come up with, in our case, Los Angeles. And if the counter is greater than 10, we're going to get out of this loop. Otherwise, we go through all 9,000 of them, and we really don't need to. The top 10 is usually enough to give you a good feel. When the routine ends, it's just end routine here. And there's exit routines and repeat routines and all your typical sort of ways to work things. Let's run this again. And we'll take Los Angeles like we did. And now we can look more carefully what happened. You can see where it says print odds and then city name. City name, the little dashes, simple enough. And then compare, remember the compare function output. And our 86 is what we got for Los Angeles. We printed out the city name and we printed out the country name after that. And that's how this program works. For the next program, we're going to do something which is kind of an interesting task. If you look here at the spreadsheet, you'll see that we have Bombay in India, and we have Delhi in India, we have New Delhi in India. We have quite a few cities from India, and we have quite a few cities from Japan, quite a few cities from China, and so on. And the question is, how many countries, unique countries, are in this spreadsheet? And for each of these unique countries, how many cities are represented for that country? Okay. For example, the United States will have a lot of cities, and so will India. and so will Japan. They're all very populated countries. They'll have a lot of cities. What we want to take a look at is just the top few of those cities. So we want to have a list of the unique countries and how many cities are in each country. And we want to know which country has the most cities first, the one that has the second most cities second, and so on. Let's see how that code works. Well, you see our world cities again. That's our same spreadsheet with a city, country, population, region, and latitude and longitude like before. We've also added another cluster in here called countries. This is a list that we got of country codes. And we got it from here, iban.com. They have a bunch of country codes. And they have the country name, an alpha code, 2-digit, and an alpha code 3, such as for United States, US is the 2-digit code, USA is the 3rd-digit code. And apparently there's a numeric code, which I'm not really familiar with, but they have all the codes in here. So we grabbed all of this data and we put it into a spreadsheet. And if we take a look, let's lower this back down. How does this work? Well, we did this because we wanted to take the 2-character country names here and we wanted to convert them into the actual full name so it's easier to, for the end user, we always care about our end users, to figure out what the name of this country is. Then we make a little heading, top 5 countries, pretty simple, quoted literals. Here's our cluster input on the world cities, just like the previous program that we did. And here's, and we talk to them too. World cities loaded, and then size. Size is a function that, given a cluster, tells you how many rows are in it. So this will tell us how many rows are in world cities, so it should be 9,000 something. And then we did a cluster input on countries, and here we can see we loaded it all. Both of them have headers. And we did our cluster input on the countries. Now we have all the countries loaded. Now we're going to do what's called a collection. Again, you saw collection in the last program, but this time we're going to do collections asking for unique occurrences. In particular, we want unique occurrences of each country. So if the country is in this cluster more than once, we just want to see it once. And by the way, we know for a fact that the country will be in this cluster more than once. Here's country, and here's India once, twice, 3 times. It'll be in here a lot of times, probably around 1,000 times or something. But we just want the unique occurrences of country. And then we want to sort descending by what's called collected. Collected says, since we're looking for unique occurrences, how many duplicates of this particular country were there? So an example is India, already over here. We already see there's at least 3, the 1, 2, 3 here. Pretending there were just 3, collected would be 3. But it's not going to be 3, of course. It'll be a much larger number. And here's our collection. We're creating our collection here and sorting descending again. You can sort on data that doesn't exist inside your cluster. Just demonstrating that again. Unique countries, we give the number of unique ones. And now we're going to rank them. Start a rank at 0. And then for each of these world cities, remember this is all going to be just the unique. The world cities has already been subsetted by the uniqueness of each country. We're going to get the city count for how many cities were represented by that particular country. And we want to make our code kind of professional looking here. So even though every single country here on this list is indeed represented, we're going to pretend for a minute that it's not, and that we might be missing some country. So we start country name out, be unknown, and then we do a lookup. We say go to the countries, alpha 2 field, take a look in world cities at that country name, such as JP for Japan, look it up. That gets the row in the countries cluster. If the country row is greater than 0, which means we found it, then we want to use a country name of whatever country said that name is. So for JP, it would be the word Japan. If the country row was not found, it's going to be 0, and we're going to stick with unknown. Now, I could have written this code saying, country row, blah, blah, blah. If country row equals 0, then country name equal unknown, else, country name equal country's country. I just don't like if then else statements a lot. It's a personal thing. I find it easier to read code if you can read it straight down. That's just a personal preference. Okay, we're going to bump up our ranking. We start rank at 0. We're going to bump it up by 1. So then we're going to say print. It's going to be a 1, country name, and then the city count. And after 5 of them, if rank's greater than or equal to 5, we're going to get out. And that is this entire program. So you try to write that program in another language, it'll be very painful unless you load in some specialty modules that do all that, some specialty libraries, whatever it is. You don't need to do that with Sheerpower. Sheerpower is extremely function rich and has all these things built into it. Let's try running this. And we run it, top 5 countries with the most world cities. Here, let's go and scroll this up a little bit. Here we go. Let's take a look at this thing running. Top 5 countries with the most world cities. You can see that's where it says it. World cities loaded. World cities loaded. We loaded in 9,268. And we can load at the rate of somewhere around 5 million rows per second. So we can really load up the data quickly for analysis. That's a lot of data. Unique countries, which we got from doing our little unique statement here. 175 countries represented in this spreadsheet. And now we'll take a look at what we discovered in the end. And we have our rank country cities, which we saw here, rank country cities. And then we have the names of the city, well, the rank, country name, city count. Rank, country name, city count, those are the 5. This press enter key to continue is done by the delay statement at the bottom of this code. Delay. Here we go. It includes native high-speed processing of very large spreadsheets, which we call clusters, and there's an example of this program that we'll be showing, and you can take a look at that. In addition, the sample will show how clusters can be searched. Clusters are what we call these spreadsheets, and we can search them really, really fast, in less than a millionth of a second, regardless of the size of the cluster. So if you have a 1,000,000 row cluster, we can search for any given occurrence in less than a millionth of a second. Really, really fast. This is done using a method called hashing combined with a method called Bloom filters. And then another method on top of that, which is something we've developed for Sheerpower, which allows our hash tables to contain duplicate keys. Duplicate keys are usually the bane of hashing if you look it up. We have no problem with that. We will be giving another YouTube video on how exactly we achieve these kinds of speeds for our cluster searches. It's an interesting thing. If you want to be super techie, we're going to be very techie on that particular one. Okay. Sheerpower can also access database records at over 100,000 database records per second. Very, very fast, with full concurrency, by the way. Concurrency means you can have multiple users in the same database at the same time, and we can in the same table, simultaneous, we can handle all that. As you saw from looking at some of the Sheerpower code, it's easy to learn, it's easy to maintain, and it's easy to debug. It's very, very straightforward. We also designed Sheerpower code, the actual code syntax itself, so it will continue to work with future releases without any changes. One thing that is very expensive for an organization is if you've written a whole bunch of code, and then, for instance, Python 2.7, right? You've written code in Python 2.7, and suddenly you go to Python version 3.8, and you discover that a whole bunch of your code doesn't work anymore because the features that you expected have been changed in some way. We don't do that. It's actually, I mean, Python's free to do that. Of course, they need to in some cases because they didn't like their syntax, or their syntax put them into a box they didn't like. C++ has the same issues. Java certainly has the same ones. We have not fallen into that trap. We are very, very careful to make sure you never have to change your code because of a future release of Sheerpower. We do this because when you change code, it means you have to touch the code. If you have to touch it, it's expensive, and you might break it. You have to retest everything. Very, very expensive. 80% of the cost of software is maintenance. It's not the actual writing of the code. It's the maintaining of the code is where all the money is. So we want to make that maintenance as easy as possible and as infrequent as possible. You don't want to be going back to old code that suddenly doesn't work. And so we guarantee that all existing code will work in future releases. We have what's called a regression test that we run that has all the old code plus any new code, and we run that regression test to make sure there are no errors whatsoever before we make a release of Sheerpower. Sheerpower also provides very consistent performance. We don't have any need for a garbage collector the way that our memory system works. We developed something very, very different where we do runtime optimizations and all kinds of tricks for memory allocation, data allocations, string allocates and deallocates. All those things, by the way, are done for you as a programmer. You do not have to do allocates or deallocates or mallocs or smart pointers or any of that stuff. Sheerpower handles all this. Sheerpower handles the complications with memory handling all by itself. You don't have to do it as a programmer. You have enough trouble just doing the specifications that the users have given you to then have to worry about, convincing the runtime experience of your programming language to work properly. So we don't want programmers to worry about that stuff. So we have no stop the world events at all. We have nothing like that. There's nothing blocking us. We run very, very fast and very consistently. We've also included with Sheerpower a high-performance web server. It has a very small footprint. It integrates directly into Sheerpower using memory-to-memory transfers for transactions, and we can handle thousands of transactions per second on a laptop. This concludes our first introduction to Sheerpower programming. We hope you enjoyed it, and we'll be doing some more.